Hi folks, welcome to another YouTube tutorial with Python. Today I want to focus on parallel programming with Python, specifically asynchronous parallel programming. This is going to be a skill that will really improve the speed of a lot of your Python scripts and programs. So we're going to use the multiprocessing module. We'll go ahead and get started here and kind of learn by example. So first, I have PyCharm open. I have a new project created here, multiprocessing YT for YouTube. And so let's go ahead and we'll just create a new script first off. So I'm just going to right click over here, new Python file, and I'm going to call this, we'll call it async because we're going to do asynchronous processing. And we'll talk about the differences between synchronous and asynchronous processing here as we go through the example. So let's create that script, and it's going to open up here. And the first thing I want to do is I'm going to use the multiprocessing module today. So I'm going to do import multiprocessing as MP. Okay, and multiprocessing should be included as a standard module with your Python installation. So you shouldn't have to do anything more than just do import multiprocessing. Okay, and now I want to import numpy also, or numpy, however you want to say it, as np, and I'm going to import time so that I can time how long this takes. Now the next thing I want is a function that I'm going to parallelize. And I'm just going to have a very, very basic function that I'm going to put a sleep call into so that it seems like it takes a long time to run, but really it's a simple function. So we're going to call this def my function, and I'm going to pass in an integer, which is going to be able to link things back to my original list. I'm going to pass it, and I'm going to pass in three parameters: parameter 1, parameter 2, and parameter 3. And then my function result is simply going to be result is parameter 1 squared times parameter 2 plus parameter 3. And the reason I'm doing it like this is if we were to do a sensitivity analysis, which is to assess which parameters or variables influence a function or a model the most, this would return the result that parameter 1 is the most influential. We can see that because it's squared. Parameter 2 is the second most influential because it's multiplied. And parameter 3 is the least influential because it is simply added. And a sensitivity analysis is something where you're probably going to want to use parallel programming because you could be running the same function, thousands or even millions of times depending on your analysis. Okay, and so now I'm going to put in a time sleep for 2 seconds. And that's going to simulate this as being a function or a model that takes a long time to run. And then we will return a tuple, we'll return I and the result of our function. So that's the function that we want to run. Now let's set this up with numpy we'll just run this in serial or without parallelization first to see how long it takes. Before we do that, we need to set up our parameters to put in. And so what I want to do is I'm going to do if name equals main. Oops. Need 2 underscores and then main. And let's make some parameters. We're going to do params equals np random. And we'll start out with 10 rows, 3 columns. Sorry, this needs to be a tuple because it's a shape for the array. So we parentheses in there. And then we're going to multiply this by 100 so that our values will range from 0 to 100. Random returns a random number between 0 and 1. Okay, let's make an empty results list. Let's make a time start variable. So that's going to be the current time, time.time. And now let's loop through our parameters and see how long it takes to run this. Okay, so for I in range 0 params dot shape, and we just want the number of rows, which is 0. And then we want to get the result. Oh, and I forgot one thing we should do here. We're going to add another function to get the result from this and add it to a new list. Okay, so let's do that. So let's come up here, make a new function. So we'll do def get result, and this will take the result from our function. So we'll basically pass this tuple with I in result to get result. And then we will do results dot append result, just like that. I need a colon here. Oh, I need to make a global results. And I'm making this a global because we're returning this from this function. We want access to this results. Even though we're defining results inside of a function, we're going to want access to it down here in our main script so we can print it out. So I'm defining it as a global here. Okay, so now we can come down here and we want to do get result. So this will add all our results. My function, I give our parameters I0 params I1 and params I2. So that'll pass in the row number and then each parameter for that row number. Okay, so we're good to go there. And now what we'll do is we'll print out the time it took for that to run. So let's do time in serial. And that will be the current time, which is time.time, minus time.start. And then we'll print out the results just so you can see what they look like. Okay, so there we go. We have this ready to run now. And I have these warnings because it wants 2 spaces in between each of those. And there. Okay, so we've got our function that we're calculating. We have our get result, which gets the result from the function and adds it to our global results. And then we have our script here that is going to run that. All right, so let's go ahead and run. So we'll go up to run and click run and select our async script, and I will click run. Okay, so this is going to take about 20 seconds to run because this function is pausing for 2 seconds in between. Well, it's pausing for 2 seconds each time it runs this function. So right here, pausing for 2 seconds. So that should finish up in about 20 seconds. We should get a time in serial, and this should be about 20 when it wraps up. I'm just going to pause this while this finishes. Okay, there you go. So you can see that we had time in serial. It was just barely over 20 seconds. And here's our results. So we have the row and the value that came out of the function for that row. Now notice how these rows are all in order. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it ran those in order. And so when we run this with asynchronous parallelization, these row numbers will not be returned in order. So you can't use asynchronous parallelization if, let's say for example, the result from row 1 depended on the result from row 0. We couldn't do that because we don't know which row is going to get returned first. Okay, so we have that. So now let's go and let's do this and run this with the parallelization. And it's actually pretty simple to do. So all we need to do here is we're just going to have to modify some things here. So we're going to keep our results the same, we're going to keep TS the same, and we're going to keep params the same. I'm going to come down here at the end and I'm going to add a new print statement. So we'll do time in parallel, and this will be the same, oops, which will be time minus TS. I'm going to comment out this line here. And now, inside of our loop and above here, we're going to do just a couple extra things. Okay, so the first thing we're going to do is we need to get a pool, or a pool of CPUs that we can use. So with parallel processing, your computer actually has more than one CPU, at least most computers do. So my computer that I'm using right now has 4 CPUs, and each CPU has the ability to run 2 processes on it simultaneously. So I could potentially have 8 processes running simultaneously on my computer. And so we're going to set up a pool that has all of those. So I'm going to do pool equals multiprocessing dot pool. And now I need to give it the number of CPUs I want to use. And the easy way to do that is to do mp.cpu count. And this will get the count of CPUs from your computer. And let me just print out above here to show you what that looks like. So we'll do print number of CPUs available. And then we will do mp.cpu count. Okay, and so that'll print that out so you can see what that is. So now you have this pool of processors, or of, basically of processors, or of threads, or of CPUs set up. Okay, and so now we want to apply our function to that pool. So we'll do that here. I'm just going to comment out our previous line of code, and we will add a new line below it. And here we'll do pool dot apply async. So we want to apply asynchronous parallelization to the pool. We're going to give it the function name now, which is going to be my function. Okay, don't give parameters to the function, just give the function name there. And here we're going to give it the arguments for the function as a tuple. And so our arguments are going to be I, params, right, params row I, first value, params row I, second value, and params row I, third value. Okay, and so that gives us our pool. And now we need to give it a callback function. And this is where we're going to do get result. And so this is the function that gets called with the results from my function. So I'm going to start a new line here, and we'll specify callback. Oh, sorry. I need to close that. I messed up here. Okay, so we need to put the comma after that parenthesis. And now we can do callback equals get result. Just the name of the function. Don't add parentheses after it. Okay. So what's going to happen is for each of these processors, it's going to loop through everything in here. It's going to apply those values to whichever processor is available. It's going to pass these values, and it's going to use get result to record the results. Okay. And now I'll show you what this looks like, and you'll be able to see how this is going to work. And so what will happen is we're going to start with the first row. It's going to pass it here. It's going to pass in the first, however many rows we have of processors. And as soon as one of those gets done, it's going to immediately pass another one in. So let's click run and see how this works. Okay, so click run, and this will take a lot faster than 20 seconds. And so you can see that we had 8 CPUs available, and our time in parallel was 6 seconds, and we had a problem with the results. So let me just double check and make sure we are okay there. And I forgot 2 important things here. So we need to add a couple of things right now. So once we're done with this, our loop, we need to close the pool. So we need to do pool.close. And then we need to do pool.join, which will finalize those results. Okay. All right, so now we have those 2 things in there. Now we should get our results back when we run this. Sorry for the mistake. Let's go ahead and click run. And it's going to go. There you go. So that took less than 5 seconds as opposed to more than 20. And you can see here that our results right now are 0, 1, 2, 3, 4, 5, 6, 7, and those actually came out in order that time. That's really interesting. Most of the time, they will not come out in order. And we can try this again. So let's try it one more time and see if we get those results in order again. Okay, we have 8 CPUs available. And it looks like they may have come out in order again. And let's try something to see if we can get them to not come out in order, because we are doing this asynchronously. So instead of printing, let's do 4 cores and see if that gives us a little different answer. So let's go ahead and click run async. So we'll cut the number of cores in half. Even though there are 8 available, I'm only going to use 4. And they still came out in order that time. But notice how this time I put the number of cores down and the time went up. And the reason these are probably coming out in order is just a kind of a random coincidence. I bet if let's try this. Let's keep that at 4, and let's put this up to 100. And I bet you those won't come out in order this time. And so it's just starting the next one in this list as soon as one of these finishes. And it's just the way it's finishing is this function. It runs exactly 2 seconds every time, basically. And so they're finishing in sequential order. If we do this 100 times, we might see some out of order. So let's give that a run, and we will see what happens. I'll pause this while we finish, because it will take a lot longer to run with the 100 instead of 10. Okay, so that is finished up now. Let's take a look. You can see the first ones here are in order. Let's just scroll over a little farther. Okay, so here we go. We have 16, then 18, then 17. So the 17 came out of order. And I'm sure there are going to be some other ones if we continue far enough. But you get the idea that they're not always going to be in order when you use the asynchronous method. But the reason I wanted to show you asynchronous, it's a little more hard to understand. It can be a little harder to code for, but it's much more flexible if you can write your code so that you can run asynchronous parallelization. And in a future video, I'm going to show you how to do parallelization with message passing interface, which is the interface most supercomputers are going to use to break jobs up and do parallelization. And so if you can write your code in a way that it can be parallelized with async, you're going to have a much better time writing code that can be parallelized on a supercomputer. And so that's the large reason why I wanted to show you this. One other thing with multiprocessing, this module we used here, this is only going to work on something like your desktop or your laptop. It's not something you're going to be able to use well on a supercomputer. Like I said, for that you're going to need to use message passing interface, which we'll cover in a future video. But this can really speed up code dramatically, as you saw on your desktop as well. So thanks for watching this, guys. If you want the code, I have the code posted in an article on my website, and I will include the link to that in the description below. And so you can go and you can see that, and you'll have access to the code there. So once again, thanks for watching. Hope you enjoyed this video. Hope you found it useful, and hope you're able to use it to parallelize your Python code.